Now, in this video you will see the area under the responses of low pass filter and high pass filter for the pulse input. Okay. So, low pass filter means the circuit will be like this, and this is high pass filter. Here pulse input we are giving, which is having V volts from 0 to Tp, V volts from 0 to Tp, and output voltage also we know. In case of low pass filter, it is increasing and then decreasing, and in case of high pass filter, decreasing to 0 and then increasing like this. Okay. Based upon the time constant, it may reach up to V volts or it may not reach up to V volts. Okay. So, all these things we know. So, for this output we have to calculate the area, okay, which is under this particular curve. So, if you observe one thing here, two different curves are there. One is increasing curve from 0 to Tp and decreasing curve from Tp to infinity. These are the time limits. Okay. So, 0 to Tp we will take one curve. So, this one I am representing with V01 and second curve I am representing with V02. Okay. Similarly, in case of high pass filter also, this is V01 and this is V02. V01 is actually from 0 to Tp and V02 is from Tp to infinity. In case of high pass filter also, V01 is from 0 to Tp and V02 is from Tp to infinity. And before going to calculate the area directly, we will do some analysis here. Why we are calculating area means, if you see the DC formula, okay, DC content available in the signal formula, that is involving the area. That is why we are calculating the area here. So, what is the area under the input pulse? Input is a rectangle pulse. So, its area under input signal under pulse input, otherwise under pulse input is equal to V into Tp. This is the area under input. So, when you apply the DC signal here, okay, what will happen to voltages across the elements available in the circuit? For DC, frequency is 0. Here I am writing for DC frequency 0. So, impedance offered by the capacitor is 1 by j omega c. So, it will become infinity because frequency is 0. Impedance offered by the capacitor is infinity means the capacitor can be replaced by open circuit. When the capacitor is replaced by open circuit, input low DC is available. So, because it is open circuit, current is equal to 0. If current is 0 according to Ohm's law, resistor will not take any voltage. Okay, V is equal to I into R, because I is 0, voltage is 0. But KVL is to be satisfied. In the input we have DC voltage, resistor is not taking any voltage, that means same DC should be coming to the output. Okay. So, input DC is equal to output DC. Resistor is not taking any voltage. Same concept we will apply for the high pass filter, same thing. Okay. Input DC, frequency 0, ZC infinity, capacitor open circuit. Here capacitor is available, here resistor is there. Here output voltage we have to take, because it is open circuit, current is equal to 0, no current through the resistor. So, VR is equal to 0, but in this case V0 is VR only. So, output is 0. So, output DC is equal to 0. So, what is we have to understand here in the sense, under the low pass filter response curve, we have the DC which is exactly equal to the input DC. You see here, in the input how much amount of DC content is there, same DC should be maintained in the output in case of the low pass filter, because no DC voltage available across the resistor. Because of this same reason we can tell, since we are taking output across the resistor in case of the high pass filter, no DC is accumulated in the output. Okay. So, now with respect to curves we will understand this one. If you see the output curve like this I have taken, what area is missed here, that area is covered here. So, total area is equal to that rectangular area only. And coming to this high pass filter, it is coming like this, the output will be like this. Whatever the portion available in this area, this is actually above the x axis, same area will be available below the x axis, but it is below the x axis is nothing but negative area. If this area is A1, this area should be minus A1. So, total area is equal to 0. This is what we have to prove now according to the equations. Okay. So, V01 is equal to, we can write equation exponentially increasing equation. So, V into 1 minus e power minus t by RC. Exactly at t is equal to Tp, what is the value of V01 of Tp is nothing but t is equal to Tp, we have to substitute. So, V times 1 minus e power minus Tp by RC. This is curve. So, for clarity I am taking here V01 of t, t means variable, so that is representing the curve equation. But on that curve when you substitute t is equal to Tp, you will get the value of that curve at t is equal to Tp, that means this value. Okay. So, we will represent that one, for example V1. Okay. So, V01 of Tp is equal to V1, that is equal to V into 1 minus e power minus Tp by RC. Okay. Now, V02 of t is equal to, the second curve V02 of t is decreasing from V1, already we have V1 and it is decreasing exponentially. So, e power minus, but it is delayed by Tp seconds, already we know about this one. So, t minus Tp we have to take. Why t minus Tp? Because delayed by Tp seconds. Okay. So, these are the two equations we have now. Now, we have to integrate them to get the area. So, I am integrating V01 of t with respect to t. So, what is there? V into 1 minus e power minus t by RC, this is actually V01 of t dt. What are the limits? T is equal to 0 to Tp. So, it is equal to, I can take V constant, one integration is t, limits if you substitute Tp you will get, minus V e power minus t by RC is there. So, for e power minus t by RC, integration is e power minus t by RC, and minus 1 by RC is the derivation of the power. So, that should be written in the denominator. So, minus 1 by RC means you will get a minus RC, and limits are 0 to Tp. So, what you will get? V Tp, and if you substitute the upper limit, VRC into e power minus Tp by RC. If you substitute the lower limit, e power 0 is 1. This is what we got under the curve 1. Okay, this is equation 1 I am taking. Now, you calculate the area under curve 2, that is V02 of t dt. So, V02 of t means you see this equation where V1 is there, V1 means you can substitute what we got at t is equal to Tp. So, what is V1 now? V times 1 minus e power minus Tp by RC. This is actually V1 only, that is constant. So, second part is V1 into e power, you see this equation, we need to integrate this equation actually V02 of t. So, in this e power minus of t minus Tp is there. So, I am dividing the exponential. So, first I am writing Tp term. So, minus into minus is plus e power Tp by RC. Now, integration is to be done for e power minus t by RC. So, already we know minus RC into e power minus t by RC will come, and limits are, for this one limits are Tp to infinity, do not forget about this one. So, it is equal to, now you multiply these things first. So, minus VRC, if you multiply these two, e power Tp by RC minus e power minus Tp by RC, e power plus Tp by RC means 1 you will get. Now, if you substitute the upper limit, e power minus infinity is 0 minus e power minus Tp by Rc, like this you will get. So, it is equal to what will you get? Minus VRC into, if you multiply this one with this one, e power minus, first I am writing. So, e power plus Tp by Rc, e power minus Tp by Rc means e power 0, that is 1, minus into minus is plus, e power minus Tp by Rc. This is equation 2. That means the area under second curve. So, if you add these two, total area you will get. So, A is equal to, equation 1 is representing area 1, equation 2 is representing area 2. So, A1 plus A2, it is equal to, see here, minus 1 plus e power minus Tp by Rc. Whatever the second term is there in the area 1, that is exactly opposite to equation 2. So, this portion I will change the color, this portion will be cancelled. So, you will get simply Vtp. What is Vtp? This is actually area under the pulse. So, whatever the area is there under the pulse, same area will be maintained in the output curve of the this low pass filter. Okay, that is what we are proving. Same DC is there. Okay, whatever the DC value is there in the input, same DC will be maintained by the output of the low pass filter. That is what we are keeping here. Okay, now coming to area under the response of the high pass filter, already some explanation was given here. Now we will see, we have to prove that area under this particular thing is 0. That means area under the curve 1 must be exactly equal and opposite to area under the curve 2. So, I am writing the equations first. V naught 1 of t is exponentially decreasing. So, V into e power minus t by Rc. Okay. Then V naught 2 of t is, if it is coming from 0. Okay. Sometimes what will happen, because of the Rc, we can take output like this also. It is a generalized one. So, this curve is V naught 1 of t, this is V1, it is a value of V1, V naught 1 of t at t is equal to Tp, then it is fall down by V, that means it is V minus V, this value is V minus V, then this curve is V naught 2 of t. Okay. We will take for this one. Okay. So, V naught 1 of t is V1, V into e power minus t by Rc. Okay. Then V naught 2 of t means the starting value is this one. So, V1 minus V e power minus of t minus Tp by Rc, because it is after Tp seconds. But what is V1? V1 is the value of V naught 1 of t at t is equal to Tp, that is V times e power minus Tp by Rc. Integrate V naught 1 of t, integrate V naught 2 of t. Then you will get the sum of these two must be equal to 0. Now, we will see that one. So, integral V naught 1 of t det is equal to integral t is equal to 0 to Tp. What we will get here? V times e power minus t by Rc into det. So, it is equal to V minus Rc, if you do the integration, e power minus t by Rc, limits are 0 to Tp. So, it is equal to minus Vrc into, if you substitute the upper limit, e power minus Tp by Rc, if you substitute the lower limit, e power 0 is 1. So, that one I am writing here. Okay. This is equation 1 I am taking, or area 1. Okay. Area 1. Now, perform the integration for the curve 2. Integral V naught 2 of t dt, but if you see curve 2, we need V1 minus V, this is the voltage. What is V1? V times e power minus Tp by Rc. So, V1 minus V means we can take V common. So, if you take V common, e power minus Tp by Rc minus 1. Till here we have written V1 minus V. Next, constant e power Tp by Rc is also there, you can substitute that one. Next, e power minus t by Rc means the integration will be minus Rc into e power minus t by Rc, but here limits are Tp to infinity. Okay, you have to multiply this entire thing. So, it is equal to, okay, first I am multiplying up to this part. So, minus VRC, if you multiply two exponentials, you will get e power 0 means 1 minus e power Tp by Rc. Now, if you substitute the limits here, e power infinity is 0 minus e power minus Tp by Rc. Okay. So, if you multiply these two now, minus VRC into this is minus e power minus Tp by Rc plus e power Tp by Rc, e power minus Tp by Rc means e power 0, that is 1. Okay. Now, it is equation 2 or area 2. Now, you observe area 1 and area 2, then you will get total area A1 plus A2. See here minus VRC in area 1, here also minus VRC is there. It is e power minus Tp by Rc minus 1, but it is 1 minus e power minus Tp by Rc, both are opposite to each other. So, both will be cancelled exactly, area 1, area 2, total area will be equal to 0. That means you will not find any DC in the output of the high pass filter. That is what we are proving. These two are important. Okay. Thank you.